Okay, we stop here. Hope the slides are visible. So we stop at data analytics. So data analytics method in internal auditing include the following application types. So one is descriptive analysis and diagnostic analysis, predictive analysis, prescriptive analysis, anomaly detection, network analysis, and text analysis. So these things, as internal auditing, you should know the description of. So each one is analyzing data analytics. Explain here. Descriptive analytics is the most basic and most used method. So it concentrates on reporting of actual results. So it is only reporting on actual results. So nothing to do with the business intelligence or data, business intelligence. So this is not business intelligence. So data analytics is, the current data. You are doing little analytics. So you are different ways of reporting the actual results. So that's called descriptive analysis. So you have in your system already, you have multiple source systems, the core banking, card management system. If you take typically a bank, so core banking, card management system, ATM switch. So many systems are there. So the customers are doing transactions through these systems. So there are plenty of data is available for a bank to do a descriptive analytics. So you can report the actual results. What is his card usage? All these reports you can take it. So other than the normal reports which you are normally taking, about billing information, the credit card statements and stuff like that. So we can do reporting of actual results. So diagnostics analysis is, provide insight on, reasons of certain results occur. So we are going to diagnose for the reasons why that results has occurred. So that's called a diagnostic analysis. So these are the things which use internal auditors. So internal auditors, this is very useful. Predictive analysis. So involves applying assumption to the data and predicting the future results. So predictive analysis is you take the current data and predict the future results. The word predictive means predicting the future results. Then you have prescriptive analysis. It's concentrate on what the organization needs to do in order for predict future results to actually occur. So prescriptive means, concentrate on what organization needs to do. What are the things we have to do it in order to get the predictive future results to actually occur. So now you can do future predictive results, but all predictive results will not actually occur. So therefore, you need to know what are the actions that organization need to do. So that's called a prescriptive analysis. So government can say that we can be in 2030, like Singapore, or 2040, so but then, that future results actually to occur, you have to concentrate on what are the needs that, we have to achieve. So then anomaly detection is used to identify unusual patterns or deviation from the, the norm or expected result. So if there's expected result, there's an unusual pattern of deviation. So that we have to do it, So sometimes you can see that a person who using his bank account, for withdrawals, this is the normal regular pattern of withdrawal. But now you see that the withdrawals even happen in midnight at 12 o'clock, 2 o'clock, and things like that. So that's a little bit of a unusual deviation, patterns of deviation. So these patterns you can analyze, and the auditors can see whether that is a fraudulent act by internal employees or external customer, any other person who has, hacked his account, or maybe taken his card, or he has lost his card and somebody is using his card for withdrawals. So then these patterns we can see, analyze it. So we can see anomaly detection. And network analysis consists of analyzing network data and statistics to find patterns. So you have a network of data, so we can find different patterns of this data. That's called network analysis. So text analysis involves utilizing of text mining and natural language algorithms to find pattern in unstructured text. So we will be studying these areas in next few slides. So analysis data is another thing. So when you do analysis of data, internal audit personnel generally will select data to trace to supporting source documentation. So where the source documentation, such as invoice, contracts, and payments, and perform following additional procedures. So you get the data, but you want to trace the source documentation in order to review and confirm the details of the data selected. So, and then analyze the findings and determine compliance or non-compliance with policy. So you can see the invoices, contracts, and the payment. Whether does it whether that comply with the organization policies. So this you can do that. So also analyze to find for accuracy. So if the data you see that there is no consistency or accuracy, we can find out from data analytics. And identify internal controls required to enhance. So sometimes systems are used, but the internal controls are very poor. So if no control exists, then we can create a controls. So this is the reason why internal audit personnel, do this data analytics. And also they will communicate the results. So prior to issuing a final confirmation, the internal auditor should discuss conclusion and recommendation with appropriate management at an exit meeting. So they should discuss with appropriate management prior to final communication. So discussion provides management with an opportunity for clarification and expression of views. So let them also, we can clarify, and their views we can listen to their views also. Rather than communicating the final communication. The primary purpose of this exit meeting is to ensure the accuracy of information used by an internal auditor, because internal auditor also take this data from the source system, but there can be issues on those source systems. So we have to make sure whether we do a final communication before we do ensure the accuracy of that data. For that purpose, we will discuss this with the manager. So that's the data analytics, and then we do the data visualization. Visualization means visualize that data in a proper graphic illustration, like we do charts like pie charts, bar charts, various graphs, network analysis, written repetition like summaries, and itemized lists like bullets or numbered, are different ways to emphasize information, because data is there, but data will not provide any information. So you need to convert data into information. Data is a raw stuff, and information is meaningfulness. So in order to grab that information from that data, the visualization is important. Now you might have sales data. For example, from everyday sales data, we can take it from the system. If you have a ERP system, you can take the sales and marketing module. So you can take that data, but data in a table doesn't give any meaning. So now you can analyze. what about the monthly sales of each item? Then when you fix that also into table, but that's also not visualized. I mean, it's not also very clear. So you can't compare with the how much growth or whatever. So then you can put up a bar chart and you can say, okay, each product, last year's this month sales versus this month sales, so you can put a bar chart like that. So then a little bit of a visualization is there. So you can compare to last year October sales. This year it has grown or it has dropped down. So then you can figure out, what are the reasons why that has happened. So this visualization is very important because numbers, when you see, humanly, it's impossible. This number is double the last previous number, or this is triple. But when you see a chart, you can easily visualize it. So the data visualization is very important. So using visual aids to support discussion of major points results in most retention of information. Let me explain to you visualization a little bit. Uh, yeah, let me see whether we have a visualization. Anything? Yeah, otherwise I'll show you visualization. Okay, data visualization. Let me just show you something. I mean, this particular, if you want more information, I'm teaching data analytics and visualization for some students. So just I have taken that from that course basically. So data analytics and visualization very nicely explained in this course, in this 30-page documents, But let me just do rather than, reading this document, let me just do a small presentation on visualization. These are all included into your shared folder to get an idea, So there's a nice book which I recommend for that, this subject, for business analytics and data visualization, James Evans, third edition, very latest one. 2021. And this book, the PDF copies, I think I have attached them. Let me see. Yeah, I think I must have put it to that your shared folder. So if it is not there, I'll just put that one in. I mean, you don't have to have, that level of a deep knowledge is not expected for this course. See, put that book. This is lecture 7, 7 part B. I haven't put it, I just put that book, just after this lecture. So let me just explain a little bit of a visualization. You do it in the business day in, day out, So data visualization is a process of displaying data, often in large quantities in a meaningful fashion to provide insights that will support better decision. Management, they provide for better decision visualization. So this improves decision making visualization. It provides managers with a better analysis capabilities that reduce reliance on IT professionals. So, you don't have to have IT professionals to do visualization. So if you have a visualization tool, then a Tableau or some other Click or some other software. The managers itself can drop and drag and drop and visualize. So that improves collaboration and information sharing. So tabular data, then the example which you can see, the tabular data can be used to determine exactly how many units of certain products were sold in a particular month, or to compare one month to another month. This example in this table, you can see the product A drop in February sales, 7,792 to 7,268. Um, especially by 6.7%. But that 6.7% is not visible. You have to do a calculation and find out the difference. 7,792 divided minus 7,268 divided by 7,792. So if that calculation, if you do it, you see 6.7% is drops. So you have to do a calculation. So it is very difficult to draw a big picture conclusion by looking at this table, tabular format. So how do we see that in a little bit more visualized way? So if you just show it in this way, a visual charts. Now this every product says product A, product B, product C. You can see in the colors from Jan to December. So you can see the ups and downs of these product sales. So that will be more visualized than this tabular form. So you can see, was it double or was it just a 10% or 20% rough? This thing you can take it, by looking at. So different colors are there for different, this thing. So by looking at, you can also see which product is doing very well, like, in terms of numbers, quantity is sold. So those things you can take it when you see the visualization. I mean, if you want to create this visualization, I mean, it's not very difficult, in the Microsoft Excel, highlight the data area. I mean, this explain, I mean, anybody can do visualization with Excel also. You don't have to have a very extensive products like Tableau or any other, analytics products. So Excel distinguish between vertical and horizontal bar charts, and this next to the other slides will explain, how you can do, visualization through Excel, line charts, how to draw that, pie charts, very basic stuff, and then area charts, then energy consumption, such as things like total energy consumption, like fossil fuel consumption. These types of charts would, do, and also scatter diagrams, uh, and then, orbit charts. Uh, I mean, this all explain in this, if you just bubble charts. Now, these type of bubble charts, we do it to see, a stock comparison. Now, each one's, how much stocks they have. I mean, by looking at the cycle, you can see Apple has more stocks than Amazon or Netflix or, whatever like. So these bubble charts are very useful for visualization. You can use combination charts, So this is explained a little bit of how you can do different charts using Excel, radar charts. So this is also use, various things to represent, like whatever the first quarter results, second quarter results. So the radar charts are very, very useful in explaining such a thing by looking at the radar. You can see the quarters are represented like this way in the radar, like Q1, Q2, Q3, Q4, Q5, and Q6. You can see the numbers, how it hits, where it overlaps, all that you can see from first quarter to second quarter, the results, and, so stock charts, you can do it, geographic data, bar charts, color scale, icon sets, sparklings, so different charts. Now that particular table which I show you, product A, product B, product C. So this type of data bars you can use. So data bars will show you what is the drop, So now you can see by looking at, you can see, which month the product A has more sales, the bigger the, bar, that you can see. And you can see the product A, from Jan to Feb, I think it's like almost half, it drops their sales, by looking at, And you can see that normally product A sales has improved, from Jan, but whereas you can see product B had a real increase happening from June onwards, but not in the initial months. So this type of data bars, you can use color bars to represent this, So same Excel chart, Excel table with the color bars, which gives you much more better visualization, on data. And data bars, you can use it like this also for the represent. This is only representing the bars are not representing each product. by, this is total product. The total product source in month of Jan, till month of December, the bars are shown. So that will give you another idea of this thing. So you can use color scales based on their numerical color palette, So color coding of quantitative data is commonly called a heat map. So we are using this heat map. You can use it for visualization. So I mean, more the figure, the darker it is. So the heat map, probably the world heat map. People knows that the colors. These where the green is used, where the orange is used. Uh, and yellow is used. So this heat map type of a thing, can show it these colors, so icon sets, this type of icons we use, it is gone up or, gone down, or, these arrows provide, the meanings of that, So arrow icons that code the monthly product sales for each product as green, if they are in the top 20, product. Uh, in the data range, red if it is bottom 20, data range, and yellow if it is in between. So that's what the yellow in between arrow is showed in horizontal, in between, not the top 20 product sales for that particular month, not the bottom 10, 20, and, in between. So these spark lines are the graphics that summarize row and column data in a single cell. So this is the way that we draw it in Spark Pointing. So all this is explained. I mean, it's very friendly. I mean, you don't have to have this knowledge, but if you want to get more on, analytics, this thing, I think I'll put that book. So I mean, you can learn from that. It's very easy. It's nicely explained. How to do this chart. So some of these charts you are always familiar, day in, day out, do it, but not all the charts you're not using it, but has different charts has evolved now today, heat maps to all that, gives you a very meaningful information for your data. So that's on the data visualization, but what you need to know is this, various charts are used to aid the data, so communicate the results. So generally language should be fact-based on the neutral. But if the internal auditor is subjected to persuade an individuals to accept recommendation, words with strong or emotional connotation should be used. Auditors normally use that. Using too strong a word or a word inappropriate for a particular recipient may induce an unwanted response. High connotation language should be chosen carefully to appeal to a specific recipient. So when you communicate the results, this is the way that you use the language. I mean, you can see when you look at the COPE, meetings, which is in the YouTube, So the way that they questions, the internal auditor, that auditor general, So he used this communicating the results, he used this language very well, what are the appropriate words and what are the inappropriate way to communicate to that particular ministry or the department or the board, when they summon those people, and then they communicate, So how they communicate, also what matters, communicate the results. Um, so so there's another term called a big data. What is this big data? So the big data is a evaluating term that describe any voluminous amount, large volume of amount or structured or semi-structured or unstructured data that has potential to be mined for information. So sometimes you have to do a data mining for the information. You have to do the mining to get the information. Now, there are structured, semi-structured, and unstructured. What is structured data? The structured data refer to data with a high level of organization, like data stored in a relational data base. These are structured. So your all account balance, account information, spending patterns, all this is very structured in the core banking system. You can take from each account, each customer, or if they are using a credit card, then it will not be there in the core banking card management system. So because you can have a credit card without having a bank account in that particular bank, no? So that will be handled by the card management system. So that data is there. Those are all structured because all the spending, all that patterns, things are data is there in that system. But then you get the semi-structured data. It does not confirm the formal structure of the data models associated with the rational database or the forms of data table. However, there exists some aspect of organization, like, for example, HTML data, like a website, so there's no very structured pattern. It can have pictures or data or whatever, so those are called semi-structured data. Now, if you try to scrape the website, and take the information, but this data comes on a very semi-structured way because it has pictures, it has words, graphics, all this comes in. And then unstructured data is very big nowadays, to refer to the information that is not organized in a predefined manner. Like, for example, text heavy documents, you can see some documents are very much text heavy, audio files, video, and images. So, too much of images are there, too much of videos are there. Those are not very, you know, structured or semi structured. Because if you go to YouTube, so many videos are there. I mean, you can't call by a name or whatever, how that person has put it, how he has named it. I mean, all depends. So the searching is very difficult because the data is unstructured. The people who go to the Facebook and upload their photos and all that, I mean, they might put different descriptions, whatever it is, it's all unstructured. So large voluminous data is there today with a lot of unstructured because of the social media. I mean, every year the amount of data in the social media double, you know, create double, because that amount of data. I mean, every time you go somewhere, you take photographs, and it get uploaded into your cloud drive, automatically when your phone synchronize. And then sometimes you attach some of them to Facebook, various social media, and Instagram, you can name it, so you just communicate with them, your friends and all that, so a lot of data is there, very unstructured, because nobody has properly coded this data. This is the information that is, there's no standard way of doing that. So everyone will put pictures and put comments, and then, I mean, the responses from the people, So all this comes on a very unstructured way. So enormous amount of data, I mean, if you really look at it, you might think, okay, I mean, a lot of videos are there in YouTube. No, the amount of videos in the Facebook is more than what is there in the YouTube. I mean, then you can see, how much of videos people upload into Facebook. So enormous number of unstructured data is coming. So when you have this much data, so we call it this as a big data, big voluminous amount of structured, semi-structured. So when you want to do analytics, it will be very tough, because we call it a big data analysis. Now, think about a situation, I mean, let's say somebody has putting a Burger King. I mean, when SoftLogic put the Burger King here, I mean, Burger King do a lot of data analytics. I mean, not SoftLogic, the Burger King. So when they put the Burger King here, they will watch the social media. Social media is a big data. People put comments, people do that. So Burger King US office is, studying, the patterns and, comments on the Burger King Sri Lanka, because these are franchise operation. The SoftLogic is the franchise partner, the franchisee is, SoftLogic, franchisee is Burger King. So then they look at what are the social media comments on this Burger King. So then they found that, when they run the big data analytics, the analytics tools on social media, I mean, there are open areas where you can take the comments, and they see that the comments were saying that, the burger is small and, various things. and then they started responding to those things, and they people compare with McDonald's and everything, and then they said, the rice is not there. I mean, they responded with king rice. And so like that, you had to do a analytics on social media and come up with what they write, what good comments, bad comments, all that. You have to take it up and do that analytics. So people post videos, people post various stuff in the sometimes these are detrimental to the organization. So you have to do analytics. I mean, nobody can stop that. The people putting comments, social media, and going in. So the big data analytics is a very tough this thing because enormous amount of data is there. I mean, you can't bring that data into a single computer and do analytics. Terabytes of petabytes of data is there. So that's what we call it a big data. So big data includes information collected from social media, data from internet-enabled devices, machine data, video, and voice recording. Enormous amount of it. So then let's say if somebody wants to do a BI tool, business analytics tool, or a Tableau or something, and analyze the cricketers like Sanat Jayasuriya. So Sanat Jayasuriya, if you just looked at and try to analyze from the social media, it has to pull out a lot of data from various source systems. It's called a big data. Maybe the whatever the news that news medias, like Reuters, what they talk about Sanat Jayasuriya, and from the Crick info, they pull out the data about his records and his achievements in cricket. So from various sources, when you do a business analytics tool, and try to get that data, it comes from big data, from various Facebook page and YouTube, various places, and bring that data into you to do the analytics. So this is a huge amount of data. So the information collected is converted from low density data to high density data that has the value. So, I mean, finally, why you're doing this analytics is to figure it out some information about Sanat Jaisu. So therefore, you have to that low density data to you have to convert to high density data. I mean, what is the value what is the information that you're looking at from that big data on click info and the various writers, various sources, you are getting that data. So that analytics is very important, big data analytics, for business, I mean, for a business, you have to plan that future. Future is very, I mean, uncertain. Future is not something, very, I mean, you have a hope only, like. So to be realistic on your strategic plans and, how to do that, your strategic plan. You can't do a strategic plan, without knowing what are the future and what are the things that's happening in the market, global scale. So this information, taking it is very important, and this has to be taken from the. I mean, because those information are not there in your internal system. So I told you about in IT, various levels, like especially to really look at systems which is used in yeah yeah the executive support system. So they have to deal with the big data and machine learning, business analytics. So BI. Uh, so so these are executive support systems or decision support systems are all based on that. I mean, these things are all from internal data. MIS reports you extract from the transaction processing system. So these two are transaction data, and the MIS reports are from internal, from your source systems. You can get it. Management reports you can prepare. But if you want to plan out your 5-year forecast, things like that, you had to do to make decisions, for a business, you have to have more data, from social media analytics, you have to do that. And you have to see what is the direction, I mean, it's, you don't believe that these people are doing this many analytics, even these, there are people who are doing analytics from the TV channels, and each advertisement, each company, how much advertisement they are putting it, how much money they're spending on the advertising. So those data, they are with some people, Rupava, any IT and MTA, who is advertising. So now let's say if Maliban wants to know what Munchie is doing it, on advertising campaigns and their success and failure. So they hire those people and figure it out how much they spend on this new cream cracker to advertise, or maybe cheese cracker to advertise, and what was their success. Because you can't learn from your failures. It's very costly. You have to learn from others' failures in business world. So you have to do analytics. I mean, there are people I know that they take these video clips and say how many 30 minutes clips they are running it and for each product, how much of money, because you do, I don't have access to Maliban don't have access directly to the Munchie, the marketing budgeting and how much budget versus this thing. Sometimes you might have it. I mean, for that purpose, they are deploying spies, I mean, if you look at Mitsubishi, so Mitsubishi itself has deployed 700 spies, spying America, American businesses, So this is the world that we are living in, They spy, they use business intelligence analytics to plan their strategy. This is very important. I mean, they spy, they put their people, they go in internally to very high level and the board level. I mean, it is happening in Sri Lanka also to a greater level in Colombo, the spying businesses, and putting proxies into board, and all the state banks, I mean, they hire sometimes professionals in the board of directors, and these professionals were taken back by some of these big business people who runs private bank, and they have all the information what's going on with the state banks, where their investment coming, where their customers, who are them, and all that. So this game is in a business game. So spy and do analytics. So the large organization also spy other organization, and then also use various analytics tools to analyze. Because I mean, you don't realize when an organization has grown into 100,000 employees. I mean, if you run out of ideas or something, the organization collapse. To be in the Fortune 500 list in the world, 500 top 500 companies, it's not easy. I mean, for a decade, for 10 years to be in that list in first 100, first 500, it's not easy game. So you have to have a proper strategy. So look at from every decade to decade, some of the companies are dropping out from the 500 list, and some of them are new companies are coming in. And the companies who stayed for that last 50 years in the Fortune list are the companies who has done enormous amount of work, with data and with a lot of predictions. The industry, I mean, various ways they do it. I mean, they get the specialist and write the scenarios. I mean, there are people who can see that future. I mean, the future is going to be like this for banking industry. And they can write the scenario, okay, based on their experience in that last 50 years, and the technology, and then, global competition, and, they will say, okay, this is where it's heading it, and then they write. And all these information, the top management will take it from strategic level to plan out. Because I mean, it's not something that you can do it with whatever the data you have. It is not enough to do decisions, about the company. So this is a big challenge for when your organization get bigger and bigger, because any time that you can just, go out from that market, that can happen to smaller organization, but the impact is less. But bigger organization, the shareholders, everything, the impact is very high. So this is where to get these decision support systems and executive support system in technology plays a vital role in big data analytics. I mean, the winner or a loser is from Delta, the small fraction. If you look at the Olympics, we all can run 100 meters, maybe 15 seconds. We all can run. But the matter is for the men running at 9 seconds. I mean, below 10 seconds, 9 seconds. And then the gold medalists and the silver medalists, the difference in 100-meter run on Olympics is very millisecond, not a big difference, I mean, the people who work around on that milliseconds only will be the gold winner. The other will be silver or bronze. And who will be remembered? I mean, you will be remember only the gold medalists. There are three guys who went to moon in 1969. But all of you all can remember Neil Armstrong because he's the guy who put the foot into the moon and said these legendary words, small step for man and a giant leap for mankind. I mean, that you can remember because the Neil Armstrong. But the other two, if you ask many of them, you don't know about that other two names. So in business also, the winning is a most difficult task. You had to work around on that delta. I mean, in 2005 presidential election, Mahinda Rajapaksa has won with Ranil Wickremesinghe on 180,000 votes. 2005, I'm talking about, after Chandrika. So 180,000 votes. So it's just a matter of, both of them got about 54, 55 lakhs of votes. But that not the 55 or 56 lakhs of the votes only not make the difference. The difference were made who is going to be the president is by the 180,000 votes. So the strategies adopted by the UMP government hasn't worked out. So what were the strategies? They thought LTT will, basically vote for them. They boycott the vote. About 600,000 votes. Was not there, and only one person has voted for UMP, and I think LTT has cut his hand or something. I can't remember that day. And then they didn't work out a strategy. The Hello Rome and JVP. They know that this in the campaign, Elorume and JVPs at that time doesn't want to sit in the same, the political alliance. Because they also had a difference. They had a, fight. That's the time they were like, a little bit of a peak level at JVP and Elorume because Chandrika's Bandaranaike's government, there's a coalition party, including the JVP, run for some time, with parliamentary, ministerial positions they were holding at a few positions and they were contributed to the running the government. So they also will have this election a sizable number of votes that the prediction was that at 2005. But what UMP didn't do it is it's not the 180,000 votes difference, it's about 90,000 difference. So if you can take 90,000 out of that 100, anything more than 90,000 out of 180 is a winner. No? The difference when it is 180,000. So to get the 90,000, they have to get at least Hello Romeo or JVP into their side. So if you took one side, they can be winners. So you see the strategies, when you want to work out strategies, you have to have a proper analytics. So the winner will not be there if you can. Both major political parties can get above 50 lakhs, but the difference is a very small amount. Except this last election, there was a sizable difference with Gotabaya Rajapaksa and Sajid Premadasa, but hardly that type of a difference exists in a presidential election in Sri Lanka. So in business also the same. So we require a lot of data analytics. So let's look at that. So that's where we do this big data. So the big data is often characterized by the 4 V's. One is volume. The volume is used to describe the extreme amount of data captured over time. So depending on the amount of data required to be captured, the number of servers required would range from a single server to thousands of servers, to capture that data. And another thing is volume is the real-time sensors used in the Internet of Things, have become one of the top source of data, IoT devices. So there are plenty of IoT devices today. You can get so many things like on the IoTs, wearables are there, the watches, the wearables, they collect the data, real-time sensors. So these, even the smart buildings, too many IoT devices are there. The doors are open, all that, you don't have to put a physical locks. You can put the, fingerprint or facial iris recognition. So because of so many IoT, even the home, the lighting can be controlled by IoT devices. And even the curtains can be open or closed by the IoT devices. so many thousands of millions of IoT devices are now coming into the picture. I mean, we also at Pick Lanka, we have developed a lot of few IoT devices. One is like the smoke detectors. The product name is called Sai, and that those product smoke detectors has sold quite a lot during that gas issue time. See that the gas cylinders, gas cookers were blasting. Because there's a pressure issue with that gas quality. So people are very worried about keeping the gas cylinder in and all that. We create that sensor, and that sensor, when you keep it, and it can be operated on battery and the power as well. So that will give an alarm when there is a leakage to mobile phone. And then it's also inside the alarm in the kitchen or pantry area, so that you will not go and switch on a light if that LP gas has leaked inside the room. So then otherwise there'll be a big fire. When you switch on the light, electric spark inside the switch is good enough to have a fire there in this thing. So these devices are called IoT devices, and people develop various IoT devices in the market. I mean, that's not our major business, but we did that, as a research and development projects, and that was commercialized, that product. Now it's there. I mean, mainly that being sold in Australia part of there. They buy these devices. But Sri Lanka, of course, it's a little tough to sell these smoke detectors and all that. I mean, the people don't prioritize on now these things because now that problem is solved. And sometimes you can keep these kitchen area, pantry area very well ventilated, so that then you don't have a problem. So the Internet of Things is a network of, okay, these devices, just show you these IoTs. They are in that website. Yeah, it's not there. A different site is there. Yeah. Oh no, no, we did put that. So that goes as a different site. I can't now remember. Okay, so I'll just. So these devices are there. It's a small devices. These physical devices are provided with real-time sensors and the ability to transfer data over a network without requiring human to human or human to computer interaction. Um, um, so various, even if you look at these home appliances, all IoT. I mean, you look at even a washing machine today. I mean, that you can connect into wireless, home Wi-Fi router, and it will give you if you put in the mobile app of that washing machine, it will tell you, how many cycles is that wash, whether the tub has to be clean, or all this is there, and then you can remotely operate. I mean, if you feel that you don't want to, you want to, I mean, you're coming from office and you want to switch on the washing machine when you leave office, so that it will be all washed. You can just put it to the dry, rather than putting in the morning and evening, come and put it to the dryer. So you can do that. You can remotely operate these appliances. So this is IoT things. So like vehicles, you have a lot of IoT stuff and everyday project. So this create a lot of volume of data to the internet. So the variety is and exists in a wide variety of file types, structured data file types, generally maintained by structured query languages SQL, so which is used for managing relational databases and performing various operations on the data in them. So unstructured data files. So the data types are two types: structured data files. So your structured is, let's say, if you are in a bank, the customer mandate, it's a structured, it's all uh, fields are fields. So you enter into the DB core banking system, it's a structure. So unstructured data fields, uh, or that also can have a part of unstructured in even the mandate, because but signature also can be captured into the field. The unstructured data files are like streaming data from sensors, like text, audio, images, and video. So those are unstructured, and these are maintained in non-relational database. So no SQL. So no SQL databases. Now these are SQL databases structured. So all these, the Oracle, Microsoft SQL, these are structured. I mean, Oracle also has a no SQL version. Oracle, Microsoft SQL, MySQL, all these databases are structured. IBM DB2, all are structured. But the no SQL is Oracle also now released no SQL version, and MongoDB, and those are like no SQL. So no structure. So that means audio, images, videos will be maintained in a non-relational database. So there you can't find a relation there. In other data, you can see a relation with the, basically from one field to another field, you can relate it and, write a query, I mean, we studied that part, relation. So then the other V is, so we study volume in the big data. So the big data has a humongous amount of volume of data because of video and social media. So big data has a variety we studied. So big data has a velocity. The term velocity referred to a speed at which big data must be analyzed. So analysts must have a detailed understanding of the available data and process some sense of what answers they're looking for. So we had to do that analysis, because speed is important, because if the analysis result doesn't come faster, then no point. The computing power required to quickly process huge volume of varieties of data can overwhelm the single server or multiple servers. So organization must apply adequate computing power to big data tasks to achieve the desired velocity. So one such systems are like, the Hadoop, DB. Hadoop DB is the big data. So you need to give a very high computing power. Probably what you do is you put a server farm to do a big data analytics. So we required that good server farm, high-end processors, multiple servers on a VM cluster, a Hadoop cluster. So we can create instead of a virtual cluster, you can create a Hadoop cluster, and then you can do, speedy analytics. So much data you have to quickly analyze it, so that get the velocity. Uh, uh, Businesses are hesitant to invest in extensive server and storage infrastructure, because these are very expensive servers and storage. So that might only be used occasionally to complete big data tasks. So as a result, cloud computing has emerged as a primary source for hosting big data projects. So a lot of big data projects are hosted in the cloud. Another reason is you are anyway analyzing, internet, stuff, like, so internet stuff are also in the internet, so why not you have it on the cloud service provider? rather than investing on servers and storage on premise at the organization. So the other one is veracity. So veracity refer to a trustworthiness of the data. I mean, you can have the data, what if you can't trust it? So inherent discrepancies in the data collected. Um, so can the user rely on the fact the data is represented? So veracity. So the veracity is very important in whether you can trust that data. So there are four things in big data, four V's: volume, variety, velocity, and veracity. So these are the four. So there's a fifth V, uh, is more and more businesses are using big data because of the value of the information resulting from the culmination of analyzing large amount of flows and identify opportunities for improvement. So use the big data is only as a valuable as business outcome it makes possible. I mean, don't use big data for everything. So if it is really valuable, it is how businesses make use of data that allows full recognition of its true value and potential to improve decision-making capabilities and enhance positive business outcome. You can't get a positive business outcome without improving decision-making capabilities. So to improve the decision-making capabilities, you have to have a good data and analysis. So big data is big. So you can do the volume-based value, you can get a variety-based value. So value also you can get variety. So volume-based value is the more data businesses have on customers, both recent and historical, the greater the insight, the leads to generate better decision around acquiring, retaining, increasing, and managing those customer relationships. Now, let's say if you have a lot of data, about customers, and then this data is very, if you have it in the historical as well as recent data. So you can do that proper customer relationship. Now, let's say Sri Lankan Airlines has a lot of value-based, volume-based data. All the people who has traveled in Sri Lankan Airlines, the frequency of traveling, and recent and historical both. So, I mean, this data can be used to promote certain things for these valuable clients that Sri Lankan Airlines. Um, uh, then variety-based data. So in digital era, capabilities to acquire, analyze varied data is extremely valuable. So varied data in turn provide the deep insight into successful developing and personalizing customer platform for business to be more engaged and aware of the customer needs and expectation. Now, if NTB Bank has data on their core banking card management system, you might have volume of data about a customer, all the transaction he does it in the card, and what he does it in the bank, and the salaries coming into the bank, and his spending patterns, all that volume of data you might have. But so that's a volume of data about customer. But if NTB Bank can get uh, variety-based value, so how do you get the variety-based? It's if it is part of John Key's group, so John Keys will have other stuff about this customer. Maybe the hotels that this customer is visiting. Maybe that payments may be not done with NTB credit cards or whatever it is. So that NTB will not have, even though it has the volume of that client, he might carry a couple of other credit cards also. But those information you can get it from, the cinnamon chains. Cinnamon chains are all, yeah, John Keys. So they can get it from that cinnamon chain of hotels. So particular names of customers, whether how many, what is their travel plans, or they might have a ticketing, airlines, ticket booking and this. So they are partners with some airlines. So then the foreign airlines, so they can get those same names, push it into their databases and see what is their travel patterns. Now let's say you find that in a social media, and also the social media. So if you just watch the social media and he put it in the social media, so and so person, that is your customer, that I am planning to go to Singapore next week, something like that. So if that is NTB customer, so that if that information is available for that, the John Keys group with another company like Variety, as for example, the hotel or, the travel, and they can probably offer some hotel in Singapore and they are ticket also. So you can cross-sell a lot of things. I mean, it's not the same company. I mean, cross-selling means it's the same company, but here we have a variety-based value so that, the John Keys group can use that customer, which they have captured in the social media, and they know that it's a NTB client from the NTB side data. And then they know that, we can probably offer him a ticket and the accommodation at a good rate, and you can take it, So suddenly if somebody from Aiken Spence Travel calls that client and said, we have a good hotels in Singapore and all that, and he will think, where they get it, they got it from the social media, and then they said, okay, you are using NTB, credit card, so we can use that NTB credit card there. We give promotions there, and then, hey, this, so many things. Okay, so if you go on this airlines, Singapore Airlines, with that boarding pass, you can probably go to, these parks in Singapore at discounted rate. Various stuff. You can do it for same client, if you have a variety based, not the volume based value, variety based value. So this is the real application of data analytics in use cases, in various, big data. So it's a little tough, I mean, when you get these guys, who is specialized in data analytics, but you have to create the use case, and where they can get the real value out of that. So you have to watch social media, you have to watch your internal data, volume of data, and then you get the variety of data. So then you can, satisfy the customer needs and expectation. Now I mean, what you are doing actually, you don't know this client is the NTB client, he's going to Singapore. That has been captured by the data analytics, and you are offering certain promotions in Singapore hotels also in your credit card if you have tied up with those hotels. But the client also don't know sometimes these promotions are there. Or they don't know if they take a bundle this thing or a hotel and this thing and that, and then you get the travel insurance, all that from one shop with, a lot of benefits. I mean, that increase the stickiness of the client, and they know it's not just a bank, it's not just a hotel. I mean, that gives you a very greater value being in a blue chip company. You've been a SPU of a blue chip company. So which other banks may not be able to offer such this thing. So you get the stickiness of the client, and the client may not go to another bank, and he will go and give his experience to other people, and they'll also probably open up the accounts with your bank. So this is an enormous amount of use cases that you can build up with data analytics. When you come to volume, variety, and velocity. So velocity is the faster business process data. The more time they have to ask the right questions and seek answers. So you have to have the rapid analysis capability, provide business with the right data. I mean, the knowing that the customer is already gone to Singapore is no use. You can't offer anything. So the velocity has to be there. And the veracity also has to be there. Once the data is validated, the data transform to smart data. So collecting large amount of statistics and numbers is a little value if they cannot be relied upon the use. So, I mean, you can have the data, but, you can't rely on that. The reliability is not there. So it has to be smart data. Yeah, let's try to do these few slides and finish it up. So data analytics is so the big data uses inductive statistics and concept from nonlinear systems identification. So output is not directly proportional to the input. So you have an infer loss from large set of data to reveal relationship and dependencies or to perform prediction of outcomes and behaviors. So it can be used to analyze data to identify opportunities that includes like cost reduction. So with the big data analysis, you can do cost reduction, time reduction, new product development for optimized offerings, like which I given you a example of hotel offering, travel and all that. And you can collect the new customers through that, you know. So probably the airline will offer, these facilities, the tickets and all that. But they can tell them, okay, you open up an account in this thing, so you have enormous other benefits like insurance, various other stuff coming, and international credit card or stored value card or whatever you can offer to the client. So the big data analytics tools, complete missing piece through data fusion, which is a process of integration of data and knowledge, represent the same real world object into a consistent, accurate, and useful representation. So there are key technologies like data management and data mining. So what is data management? Data need to be high quality and well governed before they can be uh, reliably analyzed. So business need to establish repeatable processes to build and maintain standard for the data quality. So data quality is very important. Establish a master data management program. So these comes under data management. So data mining examine the large amount of data to discover patterns in the data. So that's called a data mining. So you have an enormous large amount of data, but you need to figure out the pattern. So that's called data mining, shift through all the chaotic and repetitive noise of the data. So pinpoint what is relevant, use that information to assess like outcome, then accelerate the piece of making informed decision. So that's a data mine. Now, let's say you might have a radar. You probably have, if you go to Pitruthalagala. So the Pitruthalagala radar is there. You just go and watch that radar, you can see, major part of the Sri Lanka, even beyond Sri Lanka, also in the sea, also you can see from the radar screen. So it not only shows the flights, it will not only shows it also shows the ships and a lot of items it is showing. So sometimes there can be too much of data in that radar. So you might have to mine that data, and get the exactly what it is you want it. So let's say if you have too much of data, then you have to do mining and to get what is really required. So Hadoop, which I discussed, it's an open source software framework that stores large amount of data and runs application on clusters of commodity hardware. So Hadoop is used for big data analytics, so it's a open source software framework that stores large. So if you want to store large amount of unstructured data like videos, photos and things like that, Hadoop is a good platform. And it can run on a commodity hardware. So commodity hardware means, you don't have to buy, these servers from HP, Dell, or, IBM, these branded servers. So there are commodity hardwares like, um, uh, you know, so super micro servers. Then there's another model, I can't remember. So those servers you can run, So those you don't have to spend on money on, buying HP servers, IBM servers, because these IBM HP servers are spending quite a lot of money on marketing, sales. So actual value of the server is probably 30% lesser than the price that they are quoting, because marketing activity, branding activity, they have to spend a lot of money. But if you look at, the micro servers, that, Quanta servers and super micro. So the Supermicro servers are used in, let me see, for that purpose because you can buy at 30% cheaper, in these servers, on time Supermicro. So these servers are used, Supermicro, blades and data servers, rack servers. These are the servers which is used with big data because you want to cut down your cost. As I told you, the branded servers, if you use one is, it's 30% higher because they spend money on marketing. You don't have to do marketing. You need the server to run, and these all are, I mean, that's not the only thing. And these servers are designed for big data. So much storage spaces, so it's there, so let me just show you for my product. So the blade servers, rack mount servers, you can get multiple processors, multi-processor servers. And then, let me say, I'll get a multi-processor server. And they get high processing server with the liquid cooling also, maximum configurability. I mean, you can put so many hard disks into this. And I mean, if you ask the difference between a normal commercial server with the Supermicro service, these are commodity. This is, you can have so many DIMM slots. 128 DIMM slots means you can remember how many supporting memories. So this can support 480 cores. And 128 DIMM memory slots. So 8-socket configuration. And then uh, so much storage processing you can build up on a single rack server. It's optimized. So these are optimized for big data. These are not, I mean, HP, Dell, all these commercial servers are optimized for normal database performance. So not for enormous amount of data, and it doesn't have limited slots on the server on HP, Dell, and all that, because they assume that okay, you are not going to store so many things on the server. It will be on a storage, separate storage on SAN. So these servers you can see in a single uh, blade server. How many blades are there? You can see.
Hello, I'm Bob Moore with Supermicro. We're here today to talk about the Supermicro Twin Family product line. Joining me today is Bill Chen, who's a general manager of the System Product Management team. Bill, thanks for joining.
Thank you, Bob.
As well as Josh Grossman, who's the principal product manager for the Fat Twin that we have here as well. Thanks, Josh.
Thanks, Bob.
All right, so gentlemen, this has got to be probably one of the most amazing, substantial announcements we've had in years, maybe decades, all based on the new Intel 4th generation scalable processor, which is really powering these new systems that we're going to talk about here today.
So much, I mean, you can go to this site and see, what is the, so big data. The big data, especially use Supermicro and it's another Quanta. So Quanta is the other server brands, which is used for big data. I mean, I'm not saying that you can't use others, you can use, you can see the Hadoop cluster, fully integrated Hadoop cluster. You can build with this extremely high configuration, in these servers at a cheaper price, I mean, not cheaper in the sense it is cheaper than, other commercial servers. So here you can see the fully integrated Hadoop cluster you can build. And here you can see how many performance, even the network ports, 10 gig ports are there for even the racks, with this configuration. High capacity, input output performance are optimized, high density compute, and all that. Okay, so I'm not going to go into that. It's not very, very important from the examination point of view, So Hadoop clusters you can build with commodity hardware. So that's what the commodity hardware means, So Supermicro and Quanta. Supermicro and If I'm not mistaken, this should be the spelling for it. And we did it like, I mean, when I was in just-in-time group, and we developed these Hadoop clusters for ICT agencies, for big data analytics. That's where my experience coming in building up, big data systems. So in memory analytics is another area. So analyze data from system memory instead of a secondary storage. So then you had to have so many memory. That's what 128 DIMM slots are there in this cell. So you can put enormous amount of RAM into this, So this derive immediate results by removing data preparation and analytic processing delays, because you have to process large number of data to get this thing, because when you do data mining. So enable iterative and interactive analytics scenarios more efficiently, and you can do the predictive analysis, use data, statistical algorithms, and machine learning techniques to identify likelihood of future outcome based on the historical data. So in order to do this level of analytics, you need these Hadoop clusters and in-memory analytics, So text mining is analysis text data from the web, comment fields, books, and other text-based sources through the use of machine learning or natural language processing technology, So identify the new topics and term relationship. So you extract the text data from the web. So when you want to extract the text data from the web, you have to sometimes, scrape in the web, so web scraping. Using these tools. What are those tools? Robotic process automation, RPO tools, UiPath you can use, RPO, robotic process automation, like products there are like UiPath. There are other products also. Data stripping using UiPath. So this way you can web data extraction methods are there with UiPath. You can watch. I'm not going to show these videos. So you can do scraping, because some website doesn't allow you to cut and paste their data. So you go to data and try to cut that data tables, because enormous amount of tables are there. Like, for example, if you can access some of these files, even the pricing files, sometimes it will show that in the website, but it won't show it as a table or these things. So if you have a statistics, for example, election results, so but election results, of course, in the election, this thing you can download, I think, PDF formats, but certain data in their sites, it only shows, large amount of data is there. But if you want to get into Excel or something, you can't convert, you have to scrape this and convert it,
Web scraping is a very tedious task for most website owners and developers. Today, let's learn how to use UiPath in extracting information from a website. Let's take eBay for example. What I have on my screen is a filtered search result in Amazon's Kindle. So what we're going to do is to create an automation that will extract the titles, links, and prices of the
Yeah, probably. Let me show you.
web scraping.
I'll load it in the YouTube version of that.
Web scraping is a very tedious task for most website owners and developers. Today, let's learn how to use UiPath in extracting information from a website. Let's take eBay for example. What I have on my screen is a filtered search result in Amazon's Kindle. So what we're going to do is to create an automation that will extract the titles, links, and prices of the items and save it in a CSV file through a spreadsheet. Let's get started. From the design menu, let's click on web scraping. This will open the web scraping wizard. This will give us a step-by-step and easy-to-follow guide on what to scrape. Let's click Next to indicate the item we want to scrape. The recording tool is now active. What do you
So these are very easy ways of doing web scraping. So various methods are using to get this big data on the sites, because eBay and all that, you can't just do it without doing a proper scraping, text-based data or pictures, quickly automated, because if you try to do it manually, it's a very time consuming. It's millions of records, you have to go to page by page and, copy and paste humanly, you get tired. So you use the robotic process automation. That's called robotic process automation. So RPO. So UiPath is one product. It's a product, and there are so many products. I'm only familiar with UiPath, but there are so many products there on robotic process. With this we use it even sometimes there are application like you can't integrate with another source vendor through API. So if you can't integrate with the API, what you have to do is like a user. So you logging in and collect that data and entering into that system. So then you can, if you use a human being to do that, there'll be a delay. It's not a real time, it's a near real time. But if you use a robotic process automation, it's almost like a real time. It's in. So a 2015 data analytics and leadership survey conducted by Institute of Internal Auditors Research Foundation and grant from Toronto identify that internal audit professionals recognize as a benefit of data analytics. The results of the survey as follows. So audit process is streamlined 56%. Field work time is reduced 50%. Fraudulent transaction are identified 45%. Audit scope is more consistent 40%. More adults are capable of being more audits are capable of being performed is 28%. So additionally, the survey related the following with regard to the top users of data analytics. So analyzing trends 72%, compliance monitoring 56%, detecting fraud 54%, evaluating business operation performance 48%, data visualization 40%, predictive analytics 17%, modeling, you can do data modeling 12%. So these are the results based on that survey for internal auditors they can use of these things. So any other question? We can break for take a break, 15 minutes break and start the next lecture. If you have any questions, please ask on any of these areas. So you can, I will give you, if you want to further study on analytics, that book which I have showed, I think I can give it to you, the latest copy of that. But this slide knowledge is enough for answering the question, whatever I discuss. Additional things only I just basically given examples and things like that. This is good enough to answer the MCQ question. So shall we take a 15 minutes break and then start the lecture?